everyone, my name is Anna and I'm doing a chapter 18 practice problem. Okay, so what it wants us to find is the standard cell potential and the delta G of cell of this reaction, which is 2 moles of Al plus 3 moles of iodine goes to 2 moles of Al3 plus to 6 moles of iodine minus. So for this type of problem, we're first going to want to write our half reactions, which is 2Al solid goes to 2Al3 plus aqueous. All right, so our Als are balanced, but our charges are not. So what we do here is our charge is 0, our oxidation number is 2 times 3 plus, which is plus 6. And in order to balance that out, we must have 6 electrons here. All right, our next half reaction is 3I goes to 6 of that. All right, since this is in our natural form, this oxidation number is 0. This is 1, but since there's 6 moles, we're going to multiply it by 6, so we have negative 6. In order for the charges to be equal on both sides of the equation, we must add 6 electrons here. All right, so for this half reaction, we see that oxidation number is increasing, so it's being oxidized. This also means that it's the reducing agent. And then for this, it's vice versa. Since this is decreasing, it's reducing agent, or it's reducing, and this is the oxidation agent. Sorry for the messing handwriting. That's not legible. Okay, so if we take it back to our equation, we know that the standard cell potential is equal to the potential of the cathode minus the anode. If we go back to our chart, what we'll find is 0.53 volts for the cathode minus negative 1.66 volts for the anode. Together, that equals 2.19 volts. So that's our answer. That's okay. And then the next part is we're going to find our delta G of cell. And we'll recall that delta G of cell equals negative moles of electrons times Faraday's constants times E of cell, which we just found. So it's just plug and chug. So the number of moles of electrons that we had was 6, so negative 6 moles, times Faraday's constant, 9.65 times 10 to the 4th coulombs per mole. And then for our E of cell, it's 2.19 volts equals joules per coulomb, so joules per coulomb. And altogether, this equals negative 1,268,010 joules. Converted to kilojoules equals negative 168 kilojoules. Since this question didn't specify, both answers would qualify. Thanks, and that's all we have today. Woo!